Two is too much work for me.
I said after two, that's all.
But I just don't shoot into anyone, so.
Oh, God. That's so funny. All right, here we go. Here we go. Let's see if Hunter shows or what's up.
I, oh my gosh, I hit a huge curve earlier.
I didn't even hear what you said. And I'm pretty sure I don't want to know.
That does not surprise me.
All right.
I see it.
All right, here we go. Good morning, Hunter. Good morning, Hunter.
I didn't see it until it was too late.
Okay, due Monday was ratio, proportion, similar figures. Then we need proportion, mid-segment, yada, yada, yada. Okay, so I actually have to teach some stuff today. That's cool. All right. That's the joy of having everything done like a week or two in advance, is I actually forget what we're doing, but it's always waiting on me. So here we go. Good morning. All right. First things first, I would hope that everybody has this slide right here done. And so that would mean that we're doing advanced triangles, homework. I'm going to go way out on a limb and assume everybody did okay on this one. Like if you had some challenges here, we need to talk. Okay, because what do we do here? Cross multiply. We're going to go 3 times 6 equals 3 times 6 equals. Come on, baby. Okay, yeah, it does equal 18. Good job. Okay. Woo. The only thing that might be a little confuzzling here, if I have negative 3 halves the fraction, where does the negative go? It could be this. That would be totally okay. It could be this. That would also be totally okay. You know what it can't be? It can't be that. How come? Because what's negative 3 divided by negative 2? It's not negative anymore, is it? Because 2 negatives make a positive. So that's the only thing it can't be. Now, ladies and gentlemen, this is 4th and 5th grade math. But to be fair to you, how often have you used this particular little math fact recently? Probably not a lot. But now that you've been reminded, it should be no big deal, right? Where does a negative fraction, the negative can either be in the top or the bottom. Take your pick. Makes no difference whatsoever. So let's do this. Can we do it that way right there? Is that fine? Okay, so what do we get? Negative 18 equals 2x. Then what do? Okay, guys, these are the easy questions. If you want in on the easy ones, these are the ones right here. Okay, because they're going to get worse. All right, is that okay with everybody? All right, so we're good there. Hunter, you good with that? Oh, Hunter says yes in chat. All right, good job. All right, now, what's the only thing you had to be very careful of in this type of problem? That's it. Make sure you got the right. So J goes with M. So J goes with M. So are these lined up correctly? Because could they have done this? Could they have done that and laid it around or flipped it over or made it look weird? As long as you're good here, tell me the fraction that goes with this. What are we trying to find? Hello? OM, so, okay, guys, here's what we're going to need to do. You're going to need to talk, because right now I'm working way harder at this than you are. That doesn't work for me. Does that make sense? Okay, so what are we trying to find? Oh, good job, all right. So let's set up a proportion. Here we go. What goes with what? Now, there are actually probably 4 ways I can set this up. Any of the 4 is perfectly fine. Pick one. 58 over what? 43. So she says this over this.
No. Wait a second.
It's okay if you do that.
Okay.
As long as you do what?
Do the same as the other side.
Right, which is?
25.
There you go. Is it a problem that the X is in the bottom? No, because what am I going to do? I'm going to cross multiply, right? And it's going to be 58x equals whatever 43 times 25 is, isn't it? Then what am I going to do? Divide by 58. Now, Riley, I want you to give me a different way than the way she just told me.
What do you do? 58 and 25.
58 goes with 25 because are they in the same type of spot? Yeah. Equals. What? Ooh, she's so close. 43 over x, and here's why. Did you start on this one first? That one second. So I need to start over here first, that one second. So as long as they match, it doesn't matter, right? I told you there were 4 ways to do this, right? Could we have flipped these over and said 43 to 58 as x is to 25? Yes. Could we have done this? Could we have said 25 is to 58 as x is to 43? Yeah, 4 different ways. It honestly doesn't matter as long as you compare like things to like things. That's the only thing that matters. Are we good? Okay. I assume you guys are done with this one already. So this should be nothing but review. Okay. Why did I say we needed to be careful on something like this? They're not lined up right. But can we figure it out? Which thing am I to find? KL. So, what goes with 7? 7 goes with 27. 7 to 27. Let's see here. That side to that side. I agree with that. So then equals 10 to x. Could we have all said, oh, 10 is to 7, big side to little side, as big side to little side, x over 27. Could I have said that? Could I have said the reverse of each of those? Yeah. Again, doesn't matter. Not really. The one that, well, now we'll get to that later. Okay. So are we okay with this? So that should be everything that was on those slides. Let's go back. Now, we're going to do this guy. Now, you haven't done the ed puzzle for this, I'm assuming, because it's due Wednesday. Okay? But, can somebody tell me what a mid-segment is? And look at the picture. What do you think? It's probably going to be in the middle, don't you think? I think it's the middle. I believe she's right. Here's how you get that. Let's draw a triangle. Any old triangle you want. A, B, C. If I draw a midpoint, what does a midpoint do? Cuts it in, cuts in half, 2 pieces. Do you agree? Well, can I find a midpoint over here? All right, somebody tell me where to stop for the midpoint. Like there? Did I get it right? We're not bad. We're not bad. So, are those 2 midpoints? Yeah. So guess what happens when I connect midpoints with a segment? It's a mid-segment. Again, are math people creative? No, we are not. We are not at all. So this is a mid-segment. Here's a question. If this is 10 feet long, how long do you think that red line is? 5.
That's a lot, that's a big five.
That means right there, it's mid-segment. Guess what? We cut the sides in half, so guess what we did to the other side? Cut it in half. And here's why. It's similar triangles, guys. Is this angle the same between both of them?
There is, wait,
Is angle A in this triangle and in this triangle at the same time? It is, okay. Do I have a side ratio proportional to 2, 1 to 2? Do I have the sides in a proportion of 1 to 2, 1 to 2? With an angle in the middle. So can I say these two triangles are similar? Do you agree? Which, by the way, makes this angle right here what? Congruent to that angle right there. How come? They're similar triangles. What's true about similar triangles? Their angles have to be the same, don't they? But wait a minute. What's true about this line now and this line now if those two angles are congruent? They're parallel. What's super nice about those sides being parallel? Alternate interior, alternate exterior, corresponding, all that stuff is true. Remember all that stuff that we did? Welcome back. All right, yeah, it's all back. Now, let's do something more fun. So, if this is 6, then this right here would be how big? Any? 3. Okay, if this is 4, how big is this? The whole thing, good call. Whole thing would be 8, which makes this part here 4. Let's assume this is 3.5. How big is this? Cool. Now I want everybody to do this. You ready? Turn your, there you go. Could I find the midpoint right here? How big is this part? How big is this part? Oh. Could I connect this midpoint and this midpoint? So if this whole side is 8, how big is that? Because is that a mid-segment looking this way? And could I do the same thing over here? How big is this green line? Okay. This, you can't see the green line?
No, like I don't see the mid.
Okay, okay, hold that thought. How big is this green line? 3.5. Here's why. Is this through this midpoint and this midpoint parallel to that right there? Do you agree?
Yeah.
And is it halfway up the triangle? So it's going to be exactly half as long. Do you agree?
Yeah.
Okay, so here's the deal. I actually have this triangle and this triangle. What's true about those two triangles? They are totally the same, because do they each have a side of 3.5?
Yeah.
Do they each have a side of 4?
Yeah.
Do they each have a side of 3?
Yeah.
So what do you think's true about this triangle? Does it have a side of 3.5?
Yeah.
And a side of 3? And a side of 4? Which makes it what? The same as it. So by finding 3 midpoints, midpoint, 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 I can split one triangle into 4, and they're all congruent. Okay, that's what you're going to be looking at. So if these two, that goes with this. Do you agree?
Yes.
These two goes with that, and these two go with this. The other way to think about this is if Meadows, if your quiz grades were as follows: you got a 6 out of 10 and you got an 8 out of 10, what's your quiz average?
Probably 7 out of 10.
Because what would you do? Take 2 quizzes, add them up,
Yeah.
and divide by 2. Do you agree with that? Okay. Well, Cooper, You did really well on the first quiz, but you did not do it all well on the second quiz. What's your average? 5 out of 10, right?
Yeah.
Because you got all of them the first time and none of them the second time, so your average is exactly halfway in the middle. Think about it. This is 6 units long. This is 0 units long. If I average 6 and 0, what do I come up with? 3, because is it exactly halfway? Get the idea? So no matter how you think about it. Remember those triangles that we did? Did they just come back here? Did we just use side angle side and side 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 and all that? Did we use midpoint like we talked about before? It's all back. It's all back. Oh, hey, we didn't even do the actual problem, did we? Let's do the actual problem. In the diagram below, you got all this. Y is a midpoint. Can I mark my figure? Z is a midpoint. Mark my figure. So if YZ is 28 minus X, good Lord, and VX is 66 minus 3X, how can I find X?
You do 28 minus X,
28 minus X equals,
then 2 parentheses 66.
she is so close. Why did you put the 2 up there? Because one of them is halfway, correct? One's half as long. The only problem is you chose the wrong one.
Oh.
Which one's longer here? This is the big one, right? So where should the 2 go?
From the small.
In front of the shorty, right? Now is it true? 2 shorties make one big old long one. Okay. And then can you solve this? 56 minus 2x equals 66 minus 3x. And go from there. Can we do that? Okay. That's it. We can do that. That's easy to do. Hunter, you following along thus far? Yep. Okay. And what's the other one? Similar triangles. Okay. So here's a question. Here's a question. Do you agree with me that that's halfway? And you agree with me these 2 lines are parallel? Okay. I don't actually need a triangle, do I? Here's what this says. Side splitter theorem says, if I have parallel lines, are all 3 of these parallel to each other? Okay, so it's like Wolverine. Okay? Then it means this side here is proportional to this side here, just like this side here is proportional to that side there. So if I said, this is 4, this is 2, this is 5, that is X. How would you set up a proportion? 4 goes with 2, the way 5 goes with X. Can we do that? Now, why does that work? Because technically, do we have imaginary similar triangles? We're just not looking at the tops. Okay, that's what this one says. This one is due Wednesday. Do you agree?
Yes.
Okay, and then you have constructions. And I see you guys Wednesday, don't I?
Yes.
So this was due today. You should have had all that done. This is due on Wednesday. Then we have stuff that's due Friday. Which, by the way, what do you notice about these?
There's no delta mass.
There's no delta mass. And then we have a test next Monday. Okay?